Hello, today we're going to be looking at the Raspberry Pi surveillance camera for students. We're going to be trying to record this box of food while we're inside the computer lab. And first thing we have to do is connect to the internet so that the Raspberry Pi and the computer are on the same login. First thing we have to do is power up and connect the camera and see that everything is in place, and also try and hide the camera. We then need to enable the camera from the interfacing options inside the Raspberry Pi config, and then we're good to go. Inside the motion config file, there are some changes that need to be made. We need to turn on daemon so that it works in the background, and then after that we also need to change the temporary log file, the location where it will be stored, so that we can access it easily. The video palette allows us for clear color during recording, and the power input allows us to keep it on auto so that none of the peripherals are damaged. Width and height has also been changed so that we can see a clear size of the video. The frame rate also has to be changed so that it records the video smoothly. And we've also turned on Netcam Keep Alive so that we can access it online itself. The MCAM name is turned on so that it can automatically recognize our camera device, as it's the Raspberry Pi 2. And motion detection threshold has been reduced so that it keeps recording no matter what while you're away from the camera. And noise tunes also turned on so that whenever there's noise around, it can detect that and start recording as well. Pre-capture is set to 2 so that it starts recording immediately, and the post-capture is set to 200 so that the motion is completely smooth inside the video. Event cap and max movie time is set to 0 so that the movie can be really long and without any limit. And the quality is set to 75 so that it records clearly. FFmpeg time-lapse is set to 0 and movies are set to on so that it records and saves the movies in our NAS drive folder. The bitrate is also set to 100 so that the video quality is the best possible, and the file is saved as MPEG-4, after which we also see that the STL is turned off and snapshot intervals are set to 0 so that it doesn't take photos while we're recording. It only takes the first photo that's needed. There's a small box on the side that gives us the time and date of the recording while it's recording itself in real time. So this helps us to know when each file was recorded. The target directory is set to our public location, which is on the NAS drive and disk 1, which is where our USB drive has been mounted to. And the snapshot file name keeps changing every time that you record it. That way there's no redundant files. None of the files get deleted. And the stream max rate is set to 100. That way if you want to access it through on the website, you can. And the web control port is 8080 whenever you need to connect to it. Track type is set to 0 because we're not using any motion detectors in the camera. We're just using the camera sensor and the change of pixels to start the recording. Quiet mode is on, and event end and event start is also turned off so that no changes take place on each event. On camera lost, we tried to run an auto run file for when it turns on itself, but this attempt failed as well. We don't have any MySQL databases being used to save the files, and we also have these config files enabled for when we need to start the recording and for it to search for the camera that we need. We would now like to show you a small demo recording of our Raspberry Pi project. Thank you for watching. As you can see, I was able to leave the bag in the lab and move out of the class, and this recording shows me coming back to my class with all of my items still there.